Let's take a brave volunteer. What are we looking to connect in this little mini lab we're going to do in a second? Nikki, what are we doing? Yeah, we're looking at how volume and temperature are connected. We spent this week so far looking at pressure. We're now going to put pressure to the side and look at how temperature connects to volume. With your neighbors, please take 1 minute to write your hypothesis. If I increase one, what do you think happens to the other? Talk it out and then capture your hypothesis. So you would multiply, and like your calculator, you would pop up the fraction. This times this, over. So you would do, four times 5 over 6 times 5. Oh, like solving for it. So this one is like so if you n2 alone, n2 comes up to the head, and that's where our butterfly comes in. The things that were in the butterfly don't together. Because n2 ends up over here, everyone goes to p. So then p1 and p1 to the bottom of t2, and then n2 comes to the top. It's bigger. All right. At this point, you and your neighbors should have your beautiful hypothesis shaken out. Do what, 15 more seconds. Every paper should have a hypothesis. Brian, Adrian, look at you. Every paper should have a hypothesis. Once you've written your hypothesis, look at the procedure. Take 30 seconds just to read what we're doing before I explain a couple of common mistakes folks make. If I increase 1, what would happen to the other? So if I increase the temperature, it's kinetic molecular theory explaining the particles. All right, pressure. Oh, that was so sad. Pressure. I had like 8 people that time. Let's start again. Pressure. There might be a lot from my head up. So, a couple of things I want to clarify. First, there are a ton of people on step number 1 that do this the wrong way. A lot of folks were like, oh, miss, I'm up at the bottom of the soda can and bubble. Will this seal the soda can? No. You should put it mouth side down. Give it a nice little slosh in your soapy water. And you should see a bubble form over the top of the mouth of the can. If it pops, what do? Just do it again, right? Reusable material. When you put your hands around it, please don't crush it. You want to make sure your hands go nice and tight around the soda can, but don't crumble anything. For the alcohol mix, on step 4, it says to use a cotton, like spray and soapy water everywhere. On step 4, it says to use a cotton ball. I couldn't find cotton balls, we can paper towels this morning instead. My recommendation, when I bring this to your table, is just to kind of tear off a little piece of it, fold it nicely, dip it in your alcohol solution, kind of paint the sides of the soda can, and watch what happens to that bubble. You and your neighbors will have 6 minutes to do the entire page. Data filled in, questions at the bottom answered. We need to think about how volume and temperature connect to each other. Questions? Okay. 6 minutes with your neighbors. Go for it.
Así no.
Like you just splash around a little bit and then pick it up. And you should see a bubble in the top of the kind of slosh a little bit. You're welcome to use both soda cans if I gave you 2. 5 more minutes. 5 more minutes.
Oh, I told you it wouldn't be all.
5 minutes even. Thank you. The one table there is capturing data, filling in what happens as they gently grasp your soda can.
Michael, what?
You're welcome to use both hands by game or table 2. You're just rubbing out. So then I would let your hands, so I would hold it just to the top. So get your hands up and hold just to the top so you can paint the sides. 3 minutes, 57 seconds.
Man, look, it's still involved.
Look at the 5 tables, this is capture data. Should capture data,
How far is it going down?
3 minutes, 21 seconds. You should have your data table mostly filled in. You're putting the finishing touches on your data table, answering the questions on the bottom question. Yeah, so you just dip a little bit in it. Make sure your bubble ready to go. I mean, I'm just going to paint the sides with the options.
No!
Oh, there. Wait, no, inside. 2 minutes, 45 seconds. So you wanna, so you wanna just like hold the can on the top and then paint. Did you get it wet? Okay. So, then what do you see happening to the bubble?
Yes.
Yes. Somebody just asked. Which one asked? Just ask. So the alcohol can have really and that leaves the can really cold. So like what? It has an evaporation point. So alcohol evaporates much faster than water does. So the alcohol in the can evaporates really quickly and pulls the can out. So the can gets cold. That's part of why we were cooking with like wine or something.
Is that where like alcohol is all with all this cold?
Because yeah, it had a little bit colder feel. Also because it just evaporates. Because when we cook with alcohol, it tend to like wine or whatever, you like put it on, you scrape it on the pan, you know, this wine evaporates off much faster than like water. So there's kind of the sugar and flavor, that's what most of it is.
Stronger than alcohol.
Yes. 1 minute, 17 seconds. You should have your data table all filled in. And answer those 2 questions on the bottom. It's Genesis and Adrian Lee.
Oh, it's up. Hey, Ryan, put your hand.
First bottom 2 questions.
Oh. Ryan, put your hand.
You should have your whole data table filled in. Your whole data table filled in. Questions on the bottom answer. 40 more seconds. Have your whole page filled in. You should have those 2 questions on bottom filled in. How did your hypothesis do? Were you right? Were you wrong? And what kind of relationship do we have happening here? Yeah, probably. More seconds. All right. You and your neighbors have the next minute. Make sure your table is dry and clean. You should keep the alcohol on your table, keep the bubbles, keep the cans, but there should be no wet spots on your tables. If you need more paper towels, I have more up front. 1 minute to be clean and beautiful. No weird wet spots on your table. Bless you. If you need paper towel, I have them. There's more up there. Yeah, I got a little more. They keep not refilling it back. I don't know. I'm clear. About 35 seconds to clean, dry tables. All your little bits of paper towels should get thrown away in the dry and the wet. Make sure your tables nice and dry. You don't have like a random wet spot on your table. Love it. All right, pressure. That's better. All right, I want to see a vote. If you think this is an inverse relationship point to the wall, direct point to the window, what kind of relationship did we observe here? Inverse, direct. What was happening? Inverse, direct. Inverse, direct. We're going to cut more votes. Inverse, direct. It is a direct relationship. When I increase the temperature with my hands, what did happen to the volume of the bubble? It also increases. Direct relationships go the same way, inverses go opposite ways. This makes sense. If I'm increasing temperature, what are the particles doing? If I increase temperature, what physically happens to the particles?
Evaporating.
They move how? Faster. They have more energy than they did before. As they move faster, are they going to hit each other more or less? Way more, which causes more pressure. But because the bubble is exposed to the pressure out here, those pressures have to stay equal. So that bubble expands to keep that pressure equal, giving us a bigger and bigger and bigger volume instead of our bubble. Go and flip over to page 15. 15? Yeah, 15. This is called Charles' law. Yesterday we learned about Boyle's law connecting pressure and volume. Today is all about Charles' temperature and volume.